In this video, I'm going to talk about the parts of a neuron. This is my lovely neuron, as well as some aspects of brain development that you need to know connected to Chapter 3. So first off, the neuron. The neuron is the basic cell in a nervous system. Nerves are basically just a bunch of neurons put together. And what these neurons do is that they send messages to each other. The point of the nervous system is to send messages through your body, so of course the basic cell in the nervous system, the neurons, do that message sending. The neuron has a few parts that you need to know. I am color coding them for you. You need to know the dendrites, the axon with the myelin, the terminal branches, and then I've also added the soma or cell body, although your book does not go into as much detail with that. So these are the different parts you need to know. For the purposes of this, we're going to start with one end and move our way down. This end here, these green things, are called the dendrites, and the dendrites are going to receive information from other neurons. So the message is always going to come in through the dendrite and move this way through the neuron. You are never going to have information go the other way. So once the information comes in through the dendrites, it goes through the rest of the length of the neuron, making a quick stop at the soma. The soma is the control center for the neuron. The soma can also be called the cell body. This really decides, is this a message that should be carried on, and it helps decide what's going to go on with this neuron. So yes, this is a message that's going to go on. Then it travels through this long tube-like structure, what is black in this neuron. This is the longest part of the neuron, and this is called the axon. You will notice these little red things that are on the axon. Those little red things are called myelin, sometimes called myelin sheaths. Myelin is a fatty substance, and just like what fat does in your body, the rest of your body, it does the same thing for your neurons. It's an insulator. So the myelin around the axon helps to insulate the axon, which helps the message move through the neuron more efficiently and more effectively. So the myelin is always around the axon. And if you have a problem with your myelin, for example, if you cannot create it as much as you should, that can lead to issues. That is multiple sclerosis. That is a myelinization disorder. And so the messages going through your nervous system are slowed, which affects your ability to feel and to move. So finally, after it gets through the axon, the message has to go out to the other neurons in the line. That is done through these. Those are called the terminal branches, sometimes called axon terminals. It's the end of the axon. So these are going to be connected to other neurons. They're going to send the message on. So information always comes in through the dendrite, past that soma, through the axon, and out the axon terminals or terminal branches. And the axon is always insulated by the myelin. Now you have a lot of these neurons in your brain. In your first 2 years of life, your brain grows from 25% of its original size, what it is when you're born, to 75% of its weight, not size, but weight, by the time you are 2. So a whole lot is going on in those first couple of years. That increase in mass is because of two main things, and it leads to something else as well. The two things that cause this increase in mass, one is an increase in dendrites. You have a whole lot more of these when you are 2 than when you are first born. So if you are using a certain pathway to send a message enough times, you try to say the same word over and over again, you make the same movement, so your body says, hey, this is something I'm going to do a lot, I should probably dedicate some extra resources to it. Your body creates extra dendrites so that you can more efficiently send that message. So when you are 2, the dendrite part of your neurons that are used the most are going to look a whole lot busier, whole lot fuller than when you are first born. So that is one part. And if you don't use them, the opposite will happen. They will shrivel up and die. So that is one thing that causes an increase in mass. The other thing is the myelin. You form more and more myelin when you are young and growing. So from 2, you have significantly more myelin than when you are born. And as you age, you will lose some of this. And of course, if there's disease, you will lose some of it. So the specialization of your brain becoming more sophisticated, learning what it's supposed to be doing, is going to play a huge part in this. So there are some definitions connected to that you should know. This creation of dendrites or totally new neurons is called neurogenesis. And again, that helps your brain go from 25% of its original mass at birth to 75% at 2 years old. As your brain becomes more sophisticated, lateralization is going to occur. Lateralization is when specific parts of your brain start to do specific things. So the fact that your left hemisphere controls the right half of your body, that's lateralization. That is something that becomes more set in stone the older you are. Connected with this, you also have an enriched environment, the need for an enriched environment. This definitely connects to those dendrites growing as well. If you have what is called an enriched environment, you are going to have optimal brain development. If you do not get the environment you need, you are not going to get those neurons to grow the way that they need to, and it could permanently affect you. So for example, some babies are born with a cataract on their eye, just like old people can get. And if you have that cataract on your eye when you are born and you do not get surgery to fix it as soon as possible, the neurons that you are born with connected to vision aren't getting stimulated. They don't have that enriched environment. And so what happens is the dendrites slowly die, the myelin slowly goes away, so that if you have that cataract and it is not fixed by the time you are about 1, you will end up going totally blind, at least in the eye with the cataract. You need to be able to use something, to use that part of your brain, to use those neurons, or they will disappear. So these are all connected to the brain development, especially in the beginning part. In another video, I'll talk about some of the downsides as you're older connected to your brain.